Good morning to all. Sir Chandramouli sir, good morning. Am I audible to all?
Yes, sir, you're audible.
Yes, sir, you are right.
Chandramouli sir, good morning. Chandramouli sir. Chandramouli sir. Sir, your voice not audible. Sir, good morning.
Am I audible?
No audible, sir. No audible. Good morning, sir. Good morning.
Okay. Good morning, sir.
Sir, shall we start? Kumar sir?
Just a minute, just a minute. Sir is adjusting, not yet ready. I think.
Yes, sir. No problem.
Sir, we'll start now. Chandramouli sir will
Yeah.
start.
Yes, sir. Sure.
Okay, sir. Manoj, you can proceed.
Okay, sir, okay. So, good morning, one and all. This is our last session, last class, that means last day of our 5 days FDP, organized by Department of Computer Science, Central University of Kerala, sponsored by ATAL. And today also we have eminent personalities who are taking care of the classes. And I would like to invite Ms. Harshida to introduce the resource person for us. Harshida?
Okay, thank you, Manas. First of all, thank you to each and everyone who have gathered here for the last day of our FTP, and a warm good morning to each and everyone. Today, in this fifth day, the first session will be started by an eminent resource person. Yeah, with us we have Dr. Chandramouli, PVSSR, who is going to provide us a hands-on session on machine learning. Dr. Chandramouli, PVSSR, is the head of the Department of Computer Science, Central University of Tamil Nadu. He qualified PhD from NIT Trichy in 2009 and postgraduated from Osmania University. He has a desirable professional experience from various reputed institutes such as Central University of Tamil Nadu, NIT Jamshedpur, NIT Trichy, etc. He has sponsored several research projects as well, and also he has authored some books also. And Chandramouli also contributed as a reviewer in some of the top SCI journals. So without respect, let me invite Dr. Chandramouli, PVSSR, to start the session. Welcome you, sir.
Yeah.
Hello.
Thank you. Thank you very much for your introduction, ma'am. So I hope that now I am audible.
Yes, sir, you are right.
So I hope that you had a very great sessions in the first 4 days, and in general, and the last day means people will have a different mood. But still, I am surprised to see many people who have joined for the very first session very early. So that shows the interest of all of you and the way the our friends from the Central University of Kerala have conducted this workshop. So with this, and also I thank Kumar sir and others for giving me yet another opportunity to interact with all of you. and straight away we'll go to the session. So what I planned here is on for the regarding the hands-on. I will just explain and show some sort of a code from the scratch in machine learning, that is in using Python. I use Google Colab, and just observe that, and if at all, if it is, I will share the code at the end of the session to the coordinator so that they can share the same with all of you. So don't be hurry in parallelly doing along with me, rather than just observe that and try to understand what is happening. Okay. Let me share my screen. Sir, I think I don't have the presentation right. Yeah, now it came. So I hope that this is visible to all of you. Is my screen visible?
No, sir. Not visible, sir. Yeah.
Okay.
Now it is visible.
So,
Okay, sir.
yeah, I use Google Colab to show some demonstration. Also, let me just use PowerPoint also. I'll just switch it between these two. So in general, when we need to do some sort of a data science projects using Python, we need to have certain libraries like NumPy, Pandas, Matplotlib. Like this, some basic files, basic packages are required. This NumPy is basically covers all sort of mathematical, like a linear algebra functions. You will have it in NumPy, and in Pandas, which is basically for bringing the data from different sources into your Python environment using some data frames, and Matplotlib for all sort of view purpose or visualization purpose we use. So I'll just give some sort of a demo on Pandas, also in Matplotlib, by taking some sort of standard data set. I'll take like iris data set, and then how to do the classification of the iris data set using different classifiers. Like we have, you might have studied by this time classifiers like logistic regression, k nearest to neighbors, decision trees, support vector machine, like that. So many classifiers are there. So we'll see how these classifiers can do the classification on this data set. This is the standard data set which is used by any machine learning or data science practitioner at the beginners level, which basically has 3 classes of data. This is basically iris data set. We call it the data of 3 different types of flowers, and you will have 4 features that have been extracted from the flowers. They are, these 4 features are sepal length, sepal width, petal length, and petal width. So like this 4 features, and you have 3 classes like versicolor, virginica, and setosa. 3 different classes and 4 different features. This is basic simple data set which can be used for any beginner in order to understand the way the classifiers work and all. Later you can shift it to your own real-time data sets. But this is simple and compact, so many people will start learning from this. So I'll also prefer to use that. Okay. So let us go to the Colab environment. I hope that you are familiar with the Google Colab environment. Is anyone who is very new to Google Colab environment? Is there anyone who is new to Google Colab, so that I can just give some brief intro about the Google Colab? Otherwise, I'll directly proceed.
Participants reply yes or no.
Familiar, fine. Thank you, Joseph. So I'll just go. So here, let us see. Suppose I have some sort of a data like this, where we have a, let us say, apples and bananas. We have some 2 varieties of fruits, and person P1 wants to buy around 2 kg of apple and 3 dozens of banana. Similarly, let us say person 2 buys this quantity, and person 3 buys this quantity, and person 4 buys this quantity. Let us say simple first to start with the scratch, how the data can be created in pandas. Let us say you have a small table like this, where you have 4 different persons who want to buy fruits, 2 different types of fruits. So apples measured in kgs, and bananas measured in dozens. So person 1 wants to buy this quantity like this for different people. So if you have some data like this, so how to transform this data into the pandas environment? Let us see that. So we just say data equal to, you can just say apples, because my first column is apples data, so and the second column is the bananas data. So I'll take the first column apples and put a colon. Then I'll just give the values for that. I have the values 2, 3, 4, and 5. So 2, 3, 4, 5, and then comma. Then the next item is bananas. Three, 4, 5, 6. I'll just create like this and enter. So the data is created. Now you can visualize the data. So you'll get some sort of like this you'll get, but we need to have some tabular form. So when you just create the data like this, you can say apples 2, 3, 4, 5, bananas 3, 4, 5, 6. For a layman, it may not be a pleasing way to visualize the data. So in order to put the data into a tabular form, what we do is we need to have the pandas object. So we'll just import pandas into the Google Colab, and then we'll say, let us say purchase equal to the data object pd dot data frame, and the data frame we pass the data whatever we have created. The data which is created here, will pass it to the data frame method of the pandas object, and whatever this returns will be stored in the object purchase. Now, if you say purchase to display, you will get the same data in a tabular form you have. Okay. But what is missing is we have this data pertaining to 4 different people, P1, P2, P3, and P4. And what we have here is 0, 1, 2, 3 as the row indexes. So in order to change this into P1, P2, P3, and P4, so what we do is you can say purchase equal to PD dot data frame of data, and we have the index option is there. So index is create, and here we specify P1, P2, P3, P4, and we'll execute this. Now you can say purchase. You can see that this 0, 1, 2, 3 are replaced with P1, P2, P3, and P4. Okay. So this is how we will transfer the data from the general array like structures in Python into the data frame objects of the panda using the pandas package. Now, if you want to retrieve a particular row from this data, from this table like structure, I want to retrieve the 3rd item or 4th item. So what you can do is you have a command called purchase dot LOC. So LOC, if you give of which one, let us say P2 I want to retrieve. So it will retrieve for the P2 person, he has 3 kgs of apple and 4 dozens of banana. So you will be able to retrieve that. By specifying the row index, you can retrieve that particular corresponding one. So this is how you can basic commands you can use, and you have so many other commands available for the pandas object. Like you can see different so many options you have. So we can see all those things little later using the IRIS dataset. We will see that. So this is how a simple data, whatever you have it, we can convert it into a pandas data frame. Uh, okay. Now I'll just use iris data set. That the data set is available in a file called CSV file in my system. So I want to read that CSV file from my system and then bring that CSV file data into the pandas data frame object. So that we will see now. So I just switched off my video just to have a good bandwidth. Because I have 2 sessions continuously. Let us say from google.colab and say import files, and then you can say upload it to files.upload. When you just execute this command, it will prompt you to choose the file where is available in your system directory, so that it will go to that particular location and read the file and then brings it here. So I have that file available in this folder. So you can also, those who do not have the iris.csv that is available, you can just Google iris.csv download. You will get it from different sources. So I could able to read that CSV file. It is done 100%. And now what I will do is I will just try to open that, and for that we need to have a IO package. So we import the IO package to open that, and we'll say panda subject dot read CSV option is there. So read CSV of IO dot bytes IO of uploaded of iris.csv. So this is connected. So we have imported the files, and then through the files we have uploaded, and is available in this uploaded variable. And from there we are converting that using the read CSV command and store variable called iris. So it is available now. Now you can see this data structure, this data. We can use different commands to extract the information from the iris dataset. So we have a head command. So when you say iris.head, it will retrieve the first first 5 rows of the information. As I said, it has 4 attributes, that is sepal length, sepal width, petal length, and petal width. And species is the actual class name. So as I told, you have 3 different classes like Setosa, versicolor, and virginica. So the first few rows are available for the Setosa, and then for the other class, and then for the third class. And if you see the data, all these are the basic measurements. Metric is not mandate for us. So some measurement, it can be millimeter or centimeter, we are not bothered. We just have some information, that is the head will retrieve the first 5 rows of the information. And if you see, the indexing is done from 0 onwards. So similarly, if you want to read the first 10 rows, you can pass the 10. When you say head of with no parameter, then it will retrieve only the 5 rows that is by default you will get 5 rows of information. But if you pass, if you overwrite that 5 by you giving your own value, then it will print that many rows of information. So now I said I head of 10, I could get all the first 10 rows of the information. Without anything, I simply type iris, and then what I'll get is the complete data set can be printed. Like you will have, you can see like this, there are 150 rows and 5 columns. And out of these 5 columns, 4 columns are the attributes, and the 5th column is the actual class name. And since there are 150 rows, the indexing is done from 0 to 149. So totally for these 3 classes, you will have first 50 rows are available for Setosa, and then the second 50 rows are available for Versicolor class, and the last 50 are for the Virginica class. So like this, the data has been available for us in 4 main attributes and 1 class attribute with 150 samples of the data. And if you want to know some basic information about this data set, you will have info method available. And when you say info, you will get some very good information. Like it says class pandas.core.frame.data frame. So this is how the data is stored in the pandas core using the frame, and within the frame you have the data frame object, and you will have 150 entries ranging from 0 to 149, and the data columns total 5 columns, and each column name its indexing number. So the first 0th column indicating the sepal length, and you have 150 rows of information, and this is not null, and the data type is float 64. Like this, the first 4 attributes representing the float 64, and the 4th object, that is the 5th attribute or the 5th column, representing the species. And if you see the data type, it is object data type. So this is the basic information you will get about the data set. So any data set, if you read it, the info will give the basic preliminary information about the data set. And for a data science practitioner or any machine learning practitioner, you need to understand the data much. Means you have to spend a lot of time in knowing the data, then only you can think of what can be done. That's why most of the data scientists, what they do is they'll spend a lot of time, most of the 60 to 70% of their time, they invest it on understanding the data and how it is organized. Now, another command is there called describe, which will give some more statistical information about the data set. So this complete statistics information, you will retrieve it, and this you can see for the 4 attributes, basically the count. So you will have 150 values for the sepal length, similarly 150 for the rest of the all the attributes, and the mean sepal length, that is the average value of this first column, is around 5.84. Similarly, the average of the sepal width second column is 3.05, and for petal length average 3.75, and petal width 1.19. Similarly, the standard deviation. Then the next 5 representing the 5 quartiles of information. This is statistical information, the minimum value. Then from the minimum value to the 25%, how much data is being spread, and from the 25% to the 50%, how much data is spread, And similarly, from 50 to 75%, how much data is spread, and so from 75 to the maximum value, how much data is spread. This is how you will get 5 quartiles of information along with standard deviation, mean, and the count. You will get it this complete statistical information in using the describe method. And you have another one called shape. When you say shape, you will get the dimensions of your iris. Now the iris here is representing the pandas object available, which is containing the data about the iris.csv file. So we have used the read CSV available in the pandas and stored that in the iris. So iris.shape is complete tabular column table structure, 150 rows and 5 columns. You will get it from the shape. And now another interesting feature is if you if you have some sort of duplicates available, means let us say you have one row here having the features 5.1, 3.5, 1.4 and 0.2. So if you have the same combination again at somewhere, then it becomes a duplicate. So if we will check whether any duplicates are there or not, and if the duplicates are there, we can remove those duplicates because we don't need that repetition of the data. So for that we have let us say iris dot drop duplicates available. So if this will, so let us put it in iris1 equal to iris dot drop duplicates. And now, in order to know whether any repetition values were there, we can once again use the shape. And when you see that 3 rows of information are repeated, so those complete rows have been dropped, and totally we have only 147 rows and 5 columns available. Also, if you want to retrieve the what are all the attributes available, then you can say iris dot columns. You will get we can extract the column names using the columns from the iris. Similarly, so for a basic data science expert, first we have to get rid of the duplicate values, and that can be done very easily using the drop duplicates method. And then what we need to do is we need to check whether do you have any null values present in the data or not. So for that, because if at all null values are there, then they will be causing some problem when you are using the any classifier. So we need to first identify whether any null values are present for any column in any row. So if at all if it is present, then what to do is the next task. So let us see whether we have any null values present or not. We can say iris dot is null. So what it returns is for every row it will say false or true. Since 150 rows are there, it is displaying the first 5 rows and the last 5 rows. So this we call it as the head, we know, and the last 5 we call it as the tail. And in between the rest of the rows are there, the rest of the 140 rows. So the false indicates that there is a value present here, and similarly in every row it will check whether any data is not present or not. So if you look at this, you cannot, it will not display the rest of the information between after the 6th row up to 144 row. So how to cross check whether those values are also false or not? So what we can do is, we can say iris dot is null. then you can say sum. So when you say sum, so if you see here is null, it returns false. That represents 0. And if at all, if it is true is there, then that represents 1. So when I say iris dot is null dot sum, then it will calculate the sum on every column. So on every column, if the sum is 0, then I can understand that there is no null value present. But if it is a non-zero value, then we need to see that there is some non-zero, there is a null value present. So we can say iris dot is null dot sum. Then you can see for all the 4 different types, you have the sum equal to 0, including the species. Sometimes you have all the information, but the class may be missing. So it will check for all the 5 attributes and given the sum as 0, means that there is no null value. In every cross section of a row and column, you will have some data present over that. So that we call it as iris dot is null dot sum. So this gives us a belief that there are no null values present. Suppose let us assume that any column you have some null value, so that you can get a sum of some non-zero value. Then what to do? How to deal with those null values? So do anyone has an idea of how to deal with those null values?
Sir, can we remove those rows which are having the null values?
Okay, that is one method of removing the null values.
Or can we replace the average weightage of that value?
So you can either remove the null value or you can replace it, those null values with the average of that particular column. And we know how to get the average using the describe method. So we can get either we can treat the null values either by completely dropping those particular rows or by replacing it with the mean value or any other function. You can mathematical function, you can deploy it to replace those null values. Okay. So after doing that, then what will be our next step as a data science expert? What you will do? So we have just taken some data set and we have understood the dimensions of the data set. And after understanding the dimensions of the data set, we could able to get some basic statistical information being extracted. After extracting the statistical information, what we have done is we have checked whether any duplicate values are present or not, and if it all is there, then we have dropped them. Then we have also understood that there are no null values present. Now, what will be the next step? You can do it as a data science expert. Can anyone tell me? What Durbasish Sarkar sir, can you tell me what will be your next step in putting your next step in understanding the data? That already we have done. We have used that and drop duplicates. We used to remove that duplicate rows. Outliers, okay. So what do you mean by outlier? Normalization, okay. Outliers, some extreme values, means all the data takes some region when you plot it and 1 or 2 samples may be far away from the region. That in general we call it as a outlier. So if at all outliers were there, then you can need to do some different treatment for the outliers. And then normalization, that is one good method. What we can see, when do you need to do the normalization? Suppose when you have the data, sometimes here if you see all the data are this data, if you see the mean value, you can see 5.8, but this is 3.05, this is 3.75, and this is 1.2. So the data, even though they are all numerical real data, the ranges, if you see, they are quite little bit differ from each column. Some have a mean value is for the sepal length, we can see the range is between 4.3 to 7.9, whereas for sepal width it is from 2 to 4.4, and petal length also 1 to 6.9, large variation, and petal width 0.1 to 2.5. So like this, each column, they have a different range of data available. So what you can do is you can think of doing some normalization. And if you see in the real-time data set, some may be having a single-digit values, some may be having a 2-digit values, or some may be having the 4-digit values and all. So in all these things, whether if the data ranges differently according to the data set, whatever it means, how they have done those measurements, accordingly you'll have the data, and the data need not be in a uniform range. So the data can be put into the normal into a uniform range, that is between 0 to 1, by doing some sort of a normalization. That is one way. To fill the duplicates, is there any built-in function, or it should be completely done manually? Yeah, you can do it manually, then you can understand. If you do it manually, then you can understand, you can retrieve that particular row using the LOC command by giving is null. Wherever is that null is there, you can retrieve it and then replace it. Means you can simply write a simple Python code to replace, to fill the duplicates with some value, whatever the value. A simple 3-4 lines of Python script, you can do it to do that. Means automatically, means writing a script, a simple Python script is sufficient to do that. So let us go to here once again. And what I do is I will try to this quartile information, I will put it in the form of a box plot. Iris of sepal length and say plot. So when you say simply plot, let us see what happens. This is how you will get, means the values, and if you see the sepal length, the first value when we printed, it was 5.1, and the last value 5.9. So if you see, it started from 5.1, so close to this 5.0, you can assume that this is 5.1, and then this value is 5.9, close to this 6. So this is how the data distributed for every row. So you have in the x-axis the row indexes is totally 150, and the range of this sepal length from 4.3 to 7.9. Similarly, you can check for the other things also. Now we have another type of plot called kind box. Means box, the type of kind of plot I want is a box plot. So this will give this sort of information. So this is the quartiles, so first quartile, second, third, fourth, and fifth. So this is the first is the minimum value, the last one the maximum value, then 25% of the data, 50% of the data, and 75% of the data, and the final 100%. So similarly, you can check for other attributes also. These are all visualization of the data using different types of plots. Now I will show another interesting plot that is available in Seaborn. So we just import that Seaborn, then we'll set the style. Fix. Now here. So now what we do is we have a beautiful command method in Seaborn called pair plot. So if you do this, so hue is equal to species representing the category column. So you'll have a big graph like this, you'll get. And if you see here on the x-axis, you will have the 4 attributes, and on the y-axis, you have also the 4 attributes. And if you see the principal diagonal, you have a bar charts, and the rest you have a different plots. So if you see here, the sepal length over the top, and here also the sepal length. And we have a legend here, the blue representing the Setosa class, orange representing the versicolor, and the green representing the virginica. And if you see here, the data is the distribution of the data like this. And this type of plot is highly useful when you do the classification. This will give an insight that whether using one attribute alone, can I do the classification or not? Okay. That is what this will give. And if you see here, since you have a overlapping of the values of each class with each other class, sepal length alone is not cannot be used to do the classification, because you have overlapping. When you cannot draw a linear straight line here, when you draw a straight line here, then this data will be gone to the other class. Something you cannot draw a single straight line to do the classification. Linear classification is not possible, and even a non-linear classification is also not possible because of a huge overlapping of the data. You can see this overlapping portion, this overlapping portion. So, and also here also overlapping. So it is not possible to use sepal length alone. And if you see the sepal width, there also more than this, you have a more overlapping here. Almost every peak is almost getting merged. So here also not possible to do linear classification with this particular attribute alone. And if you see the petal length, the Setosa class, which is blue, is well separated from this versicolor and virginica with respect to the petal length. So here I can use this feature alone. If at all, if I want to do a binary classification that says that one class is Setosa and the second class is a combination of versicolor and virginica, then I can simply draw a straight line here and say that if the petal length is the range here is say around 3, greater than 3, then it may be either versicolor or virginica, and less than 3 it is Setosa. Like that I can make a decision rule and draw a straight line here and separate the 3 classes into 2 classes. But we need to make a 3-class classifier we need to design. Just for understanding purpose, I'm telling that. And also if you see petal width also you can use it to separate Setosa from versicolor and virginica. But these 2 classes have overlappings over petal length as well as petal width also. So I hope that all of you are able to follow me.
Yes, sir.
Yeah, thank you, Mariam Ishwara ma'am. So this is the simple understanding. You will get it by using this pair plot, what is happening and how the distribution of the data is there over the each class. We are able to understand. Now, if you want to do the classification, basically, I hope you couldn't see my PowerPoint. So for any classifier, if you want to use, we have listed some classifiers and all. So the data, whatever, we need to have it in X and Y. Means X representing the actual data and Y representing the class labels. And this is the feature data. So what we have it in Iris data frame, whatever, when we upload read the CSV, we have all the 4 columns: sepal length, sepal width, petal length, petal width, and then species. Like this, you have the 5 columns of data and 150 rows, saying 150 by 5 is the dimensions. Now this is our X and this is our Y. In the class labels, we generally keep it in a variable Y, and the corresponding features we will generally keep it in variable X. So what we need to do is we have to remove the species and store these first 4 columns of information into X. And then in Y, we remove all these 4 columns and keep only the species column and put it as a Y. Once you do this, then, so totally you have here also in X, you will get 150 rows and 4 columns only, because label you remove it. And in here you will have 150 by 1, because you remove all these 4 features and keep only the label. So this is how the data should be after you split the class label from the rest of the columns. And then for any classifier, in order to do some classification, the classification involves 2 steps. That is, the first step is training the classifier, and the second step is testing the classifier. So, and for training and testing, you know, to do means you have to separate this data into training part and test part. So, training part, in general, we will keep around 70% of the data in training part. So, 70% of 150 is around is 35 means around 105 rows roughly we need to keep it for training, and 45 rows we keep it for testing, means 70% we use it for training and 30% we use it for testing. It can be even 60-40 or 75-25 also. Okay. So in order to do that, how to select that 70% of the data? You have 150 rows, and from there, how to select 70%? Say 105 rows, I want to use it for training. So how do you select it? So if you do it manually, you may be biased towards some rows. So for that, you have an important, very interesting package available in Python called train test split. So that is available in scikit-learn package. So from there we will use from sklearn dot model selection. We will import train test split, and then so what this will do is this complete information of so you will have it in X, the 150 by 4 dimension data, and in Y, 150 by 1 the class labels. So what it will do is it will split this X into train X or X train and X test. Similarly, this Y, it will split into Y train and Y test. Means what are all the samples I used it for training, those corresponding labels are available in the Y train, and what are all the variables I kept it for testing, those labels are available in Y test. Like this, it will do it automatically without any biasedness. So we use that so train test split of what? Split the X data as well as the, so you can see the manual for that. Split the arrays or matrices into random, train, and test subsets. It's a quick utility that traps input validation and the next shuffle and application to input data. Means it will do it very efficiently without any user intervention. So we need to do that on X as well as on Y. And then we'll pass another parameter called random state. So this is basically used as the seed. So random state equal to, you can say 0. So when you do this, this will do the splitting of the data. We have, okay, we have not split the data, right? Okay, first we do that, and then we will, I forgot to do that. So we need to take first 4 columns and put it in X. So what we do is, means we need to do first 4 columns and put it in X is equivalent to remove the species column from the data, right? What we do is iris1 dot, iris is the original data set, iris1 after removing the duplicates. So from iris1, you simply drop the species and drop off species, and axis equal to 1 means the whole column, the vertical axis should be dropped from the iris, and then the resultant whatever you get, that is the rest of the 4 columns, put it over in X. It says the data frame object has no attribute to draw. Let me see what I have done. There is one dot draw. Species axis equal to 1. Yeah. Okay, here over the P, there was some other character was there somehow. Okay, now you could able to, now you can see the X dot head of 3. So you have no species available. So only the first 4 columns are available. So similarly now you can say Y equal to iris 1. You need only the species. So you can say iris 1 of species. So that column alone is extracted and kept it in Y. So you can say Y dot head of 3. So the first 3 rows representing the Setosa, you will get it that here. So now we'll go back to this train test split. So train test split of our data on X and Y and use the random state equal to 0. So this will return 4 variables called X train, X test, Y train, and Y test. Like this, it will return 4 different variables in that sequence. It will return. And now if you see X train dot shape, first let me show the X shape. So X is 147 rows. After removing the duplicates, now X train dot shape. So out of that, 110 rows have been taken. Roughly 70% of the data has taken. So we have no confusion at all what rows to select, how to select, and all. So randomly, the train test is split by taking that random state seed position. It will do the splitting automatically. There you can specify, and by default you have a 70-30 ratio. If you want, you can you have a parameter there to shift it to split around 60-40 or 75-25 also. So similarly, Y train dot shape, those 147 labels, you will have it in 110 labels, you will have it in Y train. And X test, the rest of the 37 rows of information is available, and the corresponding labels are available in Y test. Okay. So X test, if you see, so okay, I forgot to put Y shape. Okay, Y test. If you see now, The 37 rows, whatever it has taken, randomly it has taken, say 7th row, 24th row, 27th row, 122nd, 146, 53, 45, like this, randomly it has selected all the 37 labels, 37 rows for the testing purpose. So the 37 labels are available in YTest. Okay. Now, after doing this, what we need to do is, someone has said normalization of the data. So that also you can do it over there, because the ranges are different for every column. So what we do is, we do the normalization. So for that, we have a min-max scalar, another package available. Then use that and call the constructor of that and put it in a scalar. And now you can use fit transform extreme, similarly x test. So if you see here, x extreme, okay. Let me show the extreme dot head of 2. Okay, this becomes a numpy object now. Fine. So now if you see the data normalized between 0 to 1. So earlier they were in different ranges. Now we have done the normalization of that. And also X-test testing labels also we have done the normalization. All the 37 samples available in the X-test, they are also done normalization. And Y-train and Y-test, they are basically the class labels. We don't need to do any normalization there. Now, so now with this, we have now set up the data, so which is now ready, and we can use any classifier to test the classifier on this data. And we have a different classifiers available. So let us first start with the logistic regression. So from sklearn dot linear model, import logistic regression and say LR equal to logistic, so call the corresponding constructor. And what you need to do is just call the fit method over by passing the training samples and the corresponding labels. That's all. The logistic regression has been applied. So if you want to know the score, you can check the score on the training samples as so when you say score, so score basically returns the mean accuracy on the given test data and labels. So we are now doing it on training samples alone, and let us see what happens, how it will print the mean accuracy. So it is 93% is there for the training samples. Now if you see it on the test samples, So 86% is of accuracy is available for the test samples. So we have also different methods to do the prediction. So we actually, the score basically, it will try to fit the mean accuracy. But if you want to do the prediction, you can say LR dot predict. So pass the sample X data and store it in Y predictions. This is where your classifier's talent will be extracted. And if you see, now we have already the test sample for this test samples, corresponding labels are available in Y test. So if you see the Y test, you will have all the categories. And if your Y predictions, if you see, by predictions also you could able to get. So you can see iris setosa, the first three. So first three iris setosa like this. But that is not possible for us to do one-to-one matching, because this is a small data set. Maybe you can do it, but if your data set is very large, say your testing samples is itself is around 1,000 or more than that, then it is not possible to do that. So we need to go for some metrics. And the best metric which is generally used for the classification, we can deduce the confusion matrix, and from the confusion matrix you can predict the precision recall accuracy. So for that, what we do is we use the metrics to create the confusion matrix, and for that also we use scikit-learn. From the sklearn we import metrics, and using the metrics we will have a confusion matrix. So the confusion matrix, we will do it by passing the actual labels and the predicted labels. So the actual labels are available in Y test, and the predictions are available in the Y predictions. And this, let us say, confusion matrix is a CM. And now you print the confusion matrix. You can see, since there are three classes, confusion matrix is a 3x3 matrix. So you can basically, for a 2 class, you will have a confusion matrix like this. You will get here, you can say this is the actual classes, and this is the predictions. So positive, negative, and positive, negative, if you say, then true positive, true negative, then false positive, false negative. Like this you will have for a 2 class 2. Since now you have a 3 classes, your matrix will be 3x3 matrix. So that's why you get the confusion matrix here, a 3x3 matrix. So from this, you can see how many true positives are there for each class, and from using this you can also print the other matrix, deduce the other matrix from the confusion matrix. And before we see that other classifiers, do anyone has any doubts so far?
Participants,
No,
please
sir, it's
unmute and ask.
No, sir, it's clear.
Thank you.
Anybody have any doubts, please ask.
Also, we can do import a classification report. That gives you can say, classification report on the corresponding Y test, the actual labels and the predicted labels. So you will get this sort of a report, precision recall, the F1 score and the support. Okay, I'll put print. Yeah, now it is formatted. So you can see the precision, recall, F score and support for all the three classes, and the accuracy that is 86%, which you could see it here somewhere in the score, whatever you got. That's in 86% of the accuracy, and the macro average and weighted average, other two parameters, but mainly we look at this. Okay. Now, you other than logistic regression, you have other classifiers like k nearest neighbor classifier, decision trees, linear discriminant analysis, naive Bayesian classifier, support vector machine. Like that, you have a different classifiers are there. So I hope that the theoretical part has been already done in the previous 4 days. That's why I'm not explaining all those classifiers in detail, but I'm just showing how to use them over the sample data. So the next classifier we choose, let us say, free import session tree classifier. Then you can say call the constructor, then call the fit method and pass the training samples. Then you can check the score on the training samples. Means decision tree perfectly could able to understand the training samples and give one means 100% accuracy, and look at the test samples, 97% accuracy. You got it. And using that score we have seen, and now check the predictions. Predict X test. After doing the predictions, what we have done is printing the confusion matrix. By passing the actual labels and the prediction labels. And to print the classification report. would get the 97% accuracy. Means the decision tree looks better than logistic regression for the iris dataset. Similarly, you can check with k nearest neighbors. And all the fit. I'm just writing all in one cell itself, and then check the score on the train samples. Check the score on test samples, and then what we have done is a confusion matrix by doing the predictions. Y pred equal to KNN dot predict on X test. So after doing the predictions, confusion matrix, and then print the classification report. So all at once we do. Okay. We'll just separate these two from here. Run it. You can run this separately. Print it. Yeah, you will get KN also 97%. So here, K nearest neighbor, I don't specify any parameter, means by default it will take 5 neighbors. And now you can check for any other classifier like let us use LDA, linear discriminant analysis. So for that, sklearn dot discriminant analysis, import linear discriminant analysis, then LDA equal to linear discriminant analysis, then LDA dot fit, LDA dot score. These values are getting overlaps. Okay, we'll separate these things. Now we'll print the score on the train samples, 98%, and we will try to print the score on test samples. 100% on test samples looks amazing. Then do the predictions. And then confusion matrix. Confusion matrix. Check the confusion matrix here. And then print the classification report. So like this, you can check with other other classifiers also. So basically, for any classification, what you need to do is the data should be in X and Y. I'm just repeating it. And from this, you use the train test split and make a X train, Y train, and X test, Y test. And based on the data, you can use min-max scalar on these training and testing samples, and then call the fit, use any classifier, and call the fit method to do the training part, and then you check the score for training and testing samples, and then do the prediction method, call the predict method on the test samples, and then use the metrics to form the confusion matrix, and then print the classification report. So this cycle is common for any classifier, whether it is a standard built-in classifier or your own classifier. This process will never change. Yeah. If you have any other queries over this, you can ask me. Before we stop this session here.
సరిగా ఓపెన్ చేయి ఇంకా ఓపెన్ అవ్వాల హలో సార్ ఇది participants, if you have doubts in this session, please ask.
Yeah, thank you all.
Think it is clear.
So I think we can break, sir.
Yes sir, yes sir. We'll take break, half an hour break. 12
Yeah.
o'clock we will start. We will resume our sessions.
Okay, 12.
Yes,
So thank you very much for your patience hearing.
yes sir. Thank you, thank you.
And we will resume at 12 o'clock, and there we will see some brief introduction to simple deep learning part like convolutional neural networks. I hope it is not covered, right, sir?
Which one, sir?
Convolutional neural
No
networks.
sir, no sir, not yet covered.
Yeah. So we'll just give an insight into the CNN and take some demo on how to implement a simple CNN over some standard data set. We will see that in the next session.
Okay sir, sure sir, sure.
Yeah. So the same link or different links? Sir?
Same sir, same. This session will
Okay,
continue.
okay. So for the time being, I just leave it and join back
Yeah,
by
yes sir,
12.
yes sir, yes sir, yes.
Thank
Good
you.
sir, good, good. Thank you, thank you.
Kumar sir, the exam link.
Participants, I will share the exam link through chat box, and I will also send to your send to group mail. Okay. I'm sending to the group mail. Manas? Manas?
Yes, sir.
Okay, okay. I'm sending to the group mail. Please check the group mail.
Okay, sir.
And also I'm pasting the link in this chat box.
Yes, sir. We have got the mail.
Yeah, mail. And link also pasted in the chat box. All of you complete it. Take your own time.
Sir, up to what time we can complete? You can just.
They can take up to 4 o'clock. Okay, before
Okay.
4 o'clock you have to submit. You can use this half an hour break and lunch break. Okay, to complete the exam. 2:30 to 4 o'clock we have a soft skills training session. There yoga session is there. So all of you attend for that also. After that only valedictory will be there. I hope it is clear to all.
Yes, sir.
Okay, Manas, now you are going, na? 12:30 you are going, na?
Yes, sir. 12:30.
Okay.
Okay.
Okay. Session is good, na? Hands-on. It's very clear.
Yes, sir. Yes, sir.
It will be
It was
useful to
nice.
everybody. Yes. Okay, participants will resume session at 12 o'clock.
Okay, sir.